All right, we're discussing potential energy. So, I'm not sure entirely how clear this is in the book, but the definition of potential energy is that the change in potential energy, regardless of the source, is equal to the negative of the work done by that force if treated as an external force. In other words, the change in potential energy is the negative integral of that force dot product with respect to the displacement. Uh, that's really about as simple as it is. Usually you can rewrite it into a form where you can break it down and have it be something simpler. We'll have an example with gravitation. We'll have another example with the elastic force. But that's about the end of it. Interestingly, this means that you can turn this whole definition back around. And essentially, if you take the derivative of the potential energy with respect to some coordinate, and the negative of that, that will be equal to the force along that coordinate. More generally, if you happen to have finished third semester calculus, this becomes the negative gradient of the potential gives you back the force vector. So it can go back and forth. You can convert to potential energy by using the work, using the force, or you can get the force back by using the gradient of the potential. Alright, why does this all work? That may be a question in your mind, and what does it all mean? Well, I talked a lot about systems at the very beginning of this section, and you probably remember we were thinking about this work external is equal to the change in kinetic energy of the system. We're going to take a look at that work external for a moment. The work external can consist of many different forces. So you can have a bunch of forces that you want to keep together and have them continue to be external. And you might have one force, like maybe gravity, that you'd like to split out away from the rest. And that's equal to the change in kinetic energy. Well, if we take one of these forces out of the sum and we start dealing with it differently, we get the work external formula that we're used to, and then we get an integral of that particular force, dot product with the displacement is equal to the change in kinetic energy. Now the way this works is everything on the right hand side, so stuff over here is inside the system. And stuff on the other side is all of it outside. So, in essence, we're imagining a system where we just have our object and it is the system, and we're ignoring something else outside like the Earth. That's the setup so far. But what if we want to take that force and bring it into the system? Well, then we can mathematically just move it across the equals sign. And if we do so, we get the change in kinetic energy minus the integral of that particular force with respect to displacement. In other words, we get the negative of the work. And that is actually as simple as it is. That is how we end up taking it inside the system. It changes from being a work to being a plus potential energy term. And now, if we looked at our system and examined it, the system would contain both objects, and we now no longer consider the force between them. So, of course, there's a mutual force between the two objects. Oops, I want it to be along the line between them. Failure. There we go. So there's our F external, there's the reaction force here. They're now both internal. Newton's third law pair. Means the two forces well, F12 and F21, the two forces, add to 0. So all that's left between them is their potential energy, which we now have a definition for. It's pretty cool stuff. If you understand how this works, it means that you can generate potential energy formulas from force formulas that you probably already remember pretty readily if you happen to forget one. If you also happen to have learned third semester calculus, it means that even if you've forgotten the force, if you remember the potential energy, you can recover the force. So it's a very cool relationship. We're going to actually derive right now two different forms of potential energy for simplified gravitation and then the elastic force. When we get to the gravitation chapter, we'll get a proper form of the gravitational potential energy, which is more complicated. When you go on to your 4B or 8B class, you're doing electromagnetism, you get a bunch of other forces. You get at least two new forces. And you can find potential energies for those forces using exactly this strategy. It's really very neat. So I hope you enjoyed this. We're going to move on and actually try those examples.